Picture this. In a galaxy containing over 100 billion stars, in a universe with 2 trillion galaxies, we've been listening for alien signals for over 60 years, and we've found nothing. Not a whisper, not a hint. Complete and utter cosmic silence. But here's what should really keep you awake at night. What if that silence isn't because aliens don't exist? What if it's because something is systematically wiping them out before they can reach us? What if there's a cosmic filter so deadly, so insurmountable, that it eliminates every civilization that tries to spread across the stars? Today, we're diving into one of the most terrifying questions in all of science, the Great Filter Hypothesis. And by the end of this journey, you'll understand why some of the world's brightest minds believe that either we're impossibly special or we're doomed. Let's start with the numbers, because they're absolutely staggering. Our observable universe spans 93 billion light-years in diameter. Within this cosmic bubble, scientists estimate there are up to 10 to the power of 24 stars. That's a 1 followed by 24 zeros. To put that in perspective, that's more stars than all the grains of sand on every beach on Earth. Now, we know that planets are common. The Kepler Space Telescope showed us that most stars have planets, and a significant fraction of those exist in what we call the Goldilocks zone, that perfect distance where liquid water can exist. We're talking about billions upon billions of potentially habitable worlds just in our galaxy alone. So here's the mystery box I'm opening for you. With all these worlds, with all this time, the universe is nearly 14 billion years old. Where is everybody? This question has a name, the Fermi paradox, after physicist Enrico Fermi, who famously asked, "Where are they?" during a lunch conversation in 1950. But the more we've learned about the universe, the more puzzling this silence has become. Frank Drake tried to quantify this with his famous equation, estimating the number of communicating civilizations in our galaxy. Even with conservative estimates, the numbers suggest we should be swimming in alien signals. Yet our radio telescopes detect nothing but cosmic static. Enter Robin Hanson, an economist and researcher who proposed one of the most chilling solutions to the Fermi paradox, the Great Filter. Picture evolution not as a smooth progression, but as a treacherous obstacle course. Somewhere in this course lies a filter so difficult to pass that it eliminates almost every attempt at intelligent life. Hansen identified 9 critical steps in the journey from dead matter to galaxy-spanning civilization. 1. The formation of the right star system with habitable planets. 2. The emergence of self-replicating molecules like RNA-3, the development of simple single-cell life. 4. The evolution of complex cells with nuclei. 5. The invention of sexual reproduction. 6. The transition to multicellular organisms. 7. The emergence of intelligent tool-using animals. 8. The development of advanced civilization. 9. The explosive expansion across the galaxy. Now here's where it gets terrifying. At least one of these steps must be so improbable, so difficult, that it acts as a cosmic choke point. The question that keeps scientists up at night is simple. Where is this filter? Let's explore the first possibility, that the Great Filter lies behind us, in our evolutionary past. This would actually be good news, believe it or not. Consider the journey life took on Earth. For 3.5 billion years, that's 3/4 of Earth's existence, life remained stubbornly simple, just bacteria and archaea, floating in primordial oceans. Then, in what scientists call one of the most unlikely events in evolutionary history, something remarkable happened. A bacterial cell engulfed another bacterium, but instead of digesting it, they formed a partnership. This process, called endosymbiosis, created the first complex cell, the eukaryotic cell that every complex organism on Earth, including you, is built from. This event was so improbable that it appears to have happened only once in Earth's entire history. But that's not all. Earth survived 5 major mass extinction events, cosmic catastrophes that wiped out up to 96% of all species. Asteroid impacts, supervolcanic eruptions, climate collapses, any one of these could have reset life's clock to 0. Yet somehow we made it through. Think about it. If abiogenesis, the spark of life from non-living matter, only happens once in a trillion tries, then Earth might be one of the vanishingly few worlds where it succeeded. If the evolution of intelligence requires a perfect storm of environmental pressures, then we might be the cosmic jackpot winners. In this scenario, the universe is filled with dead worlds, and at best, simple microbes. We're not just alone. We're impossibly, astronomically lucky to exist at all. But there's another possibility, and it's far more terrifying. What if the great filter isn't behind us? What if it's ahead of us? Picture this. The universe might be littered with the ruins of civilizations that reached our level of development, maybe even surpassed it, but then hit an insurmountable wall. Something so devastating that it stops every advanced civilization from reaching the stars. What could this future filter be? The possibilities are as fascinating as they are frightening. We've already seen how close we've come to nuclear annihilation during the Cold War. The Cuban Missile Crisis brought us within hours of global thermonuclear war. As nuclear technology spreads and becomes more sophisticated, the risk only grows. A civilization that develops nuclear weapons but fails to develop the wisdom to control them faces a deadly filter. Consider this chilling statistic. The world's nuclear arsenal today contains enough firepower to destroy human civilization multiple times over. And we've only had these weapons for about 80 years, a mere blink of an eye in cosmic terms. Perhaps even more insidious is environmental collapse. Our own planet is already showing signs of strain from just a few centuries of industrial activity. Climate change, ocean acidification, mass extinction, we're conducting a planet-wide experiment with uncertain outcomes. Throughout Earth's history, civilizations have collapsed due to environmental degradation. The Maya, the Easter Island civilization, countless others fell when they outstripped their environment's ability to sustain them. Now imagine this happening on a planetary scale, with no escape route. What if every civilization, upon reaching industrialization, inevitably triggers runaway environmental collapse? What if the very technologies that make interstellar travel possible also make planetary survival impossible? Let's zoom out and consider the bigger picture. Using sophisticated surveys like the Sloan Digital Sky Survey and the Dark Energy Survey, we've mapped the large-scale structure of the universe. We see a cosmic web of galaxies connected by filaments of dark matter, with vast voids in between. This structure formed through the gravitational amplification of tiny quantum fluctuations in the early universe, a process so sensitive to initial conditions that chaos theory applies. Small changes in the beginning led to the magnificent complexity we see today. But here's what's puzzling. If advanced civilizations existed, we should see evidence of their engineering projects. Physicist Freeman Dyson proposed that energy-hungry civilizations would eventually build massive structures around their stars, Dyson spheres, to capture all available energy. These would be visible from interstellar distances as infrared anomalies. We've searched, we've looked at millions of stars, hunting for these techno-signatures, and we've found nothing. The cosmic web appears to be filled with nothing but simple, dead physical processes, as one researcher put it. So, how do we solve this mystery? Scientists are approaching it from multiple angles, like cosmic detectives gathering evidence. The James Webb Space Telescope is revolutionizing our ability to study distant worlds. It can analyze the atmospheres of exoplanets looking for biosignatures, gases that might indicate life. Oxygen combined with methane, for instance, would be a powerful sign of biological activity. But James Webb Space Telescope is also revealing surprises about the early universe. It's showing us galaxies that formed earlier and grew brighter than our models predicted. These discoveries are forcing us to revise our understanding of how quickly complexity can emerge in the cosmos. Meanwhile, projects like Breakthrough Listen are scanning millions of stars for radio signals, using instruments 50 times more sensitive than previous efforts. They're covering vast portions of the radio spectrum, searching for the electromagnetic whispers of alien civilizations. The search for gravitational waves has opened another window into the cosmos. The Laser Interferometer, Gravitational Wave Observatory, and its European counterpart Virgo can detect the ripples in space-time caused by colliding black holes and neutron stars. These standard sirens are helping us measure the universe's expansion rate with unprecedented precision. But perhaps most intriguingly, we're learning to look for signs of life in our own solar system. The subsurface oceans of moons like Europa and Enceladus might harbor microbial ecosystems. If we find even simple life elsewhere in our solar system, especially if it evolved independently, it would suggest that the filter lies ahead of us, not behind us. The implications of the Great Filter extend far beyond science. They touch the very core of what it means to be human. If the filter is behind us, it means we might be the only intelligence in the observable universe. We're not just rare, we're unique. The entire cosmic story, from the Big Bang to the formation of galaxies and stars and planets, might have been building toward this one moment, the emergence of consciousness capable of understanding itself and its place in the cosmos. Carl Sagan captured this beautifully. We are a way for the cosmos to know itself. If we're alone, then human consciousness isn't just significant. It's the universe's only way of experiencing itself, of appreciating its own beauty and complexity. But this unique status comes with profound responsibility. If we're the only intelligence, then the preservation of human civilization becomes a cosmic imperative. Our survival isn't just important for us, it's important for the universe itself. On the other hand, if the filter lies ahead of us, it suggests that intelligence might be common, but something prevents it from flourishing. Every civilization might face the same existential challenges we're grappling with today. In this scenario, our choices in the coming decades could determine not just our fate, but whether intelligence has any future in the cosmos. The urgency of this question is becoming more apparent every day. We're living through what some researchers call the crucial century, a period where our technological power is growing exponentially, but our wisdom might not be keeping pace. Consider our current challenges. Climate change is accelerating. Nuclear weapons are proliferating. We're on the verge of creating artificial general intelligence. We're also developing biotechnology that could be used to create devastating pandemics. Any one of these could serve as a filter, but we're also making unprecedented progress in understanding these risks. We have climate scientists modeling future scenarios. We have AI safety researchers working on the alignment problem. We have biosafety experts developing protocols for dangerous research. The question is, are we moving fast enough? Are we wise enough to navigate these challenges without triggering our own extinction? Some researchers suggest that the filter might not be a single catastrophic event, but rather a gradual decline. Civilizations might simply lose the motivation to expand beyond their home planets. Why venture into the hostile environment of space when you can create perfect virtual realities at home? This great stagnation could explain the cosmic silence just as effectively as extinction. As we near the end of our journey through this cosmic mystery, we're left with questions that penetrate to the heart of existence itself. Are we the universe's only attempt at understanding itself? Or are we part of a cosmic community we haven't yet learned to detect? Are we alone by astronomical chance? Or are we alone because something systematically eliminates intelligence before it can spread? The answer matters more than almost anything else we could discover. It shapes how we see ourselves, how we value our civilization, and how urgently we need to address the existential risks we face. If we're alone, then every human life carries the weight of cosmic significance. We're not just individuals, we're the universe's only known way of experiencing love, art, music, and wonder. The death of our species would be the end of consciousness itself, at least in our cosmic neighborhood. If we're not alone, but something filters out advanced civilizations, then we're in a race against time. We need to identify and overcome whatever challenge has stopped every other intelligence from reaching the stars. Here's what makes this moment in history so crucial. We might be the first generation to face these questions not as philosophical curiosities, but as practical challenges requiring immediate action. We're developing the technology to detect biosignatures on distant worlds. We're creating artificial intelligence that could surpass human capabilities. We're grappling with climate change, nuclear weapons, and biotechnology. We're literally living through the era that might determine whether the great filter is in our past or our future. The silence of the cosmos isn't just a scientific puzzle, it's a call to action. It's telling us that intelligence, consciousness, and civilization are precious beyond measure. Whether we're alone or part of a pattern that repeatedly fails, our response must be the same. We must do everything in our power to ensure that human intelligence survives and flourishes. We need to solve climate change. We need to prevent nuclear war. We need to develop AI safely. We need to spread beyond Earth to protect ourselves from planetary catastrophes. Most importantly, we need to grow wise enough to handle the immense power our technology is giving us. The Great Filter isn't just a hypothesis about alien civilizations. It's a mirror reflecting our own challenges back at us. And that mirror is asking us a simple question. Will we be the intelligence that finally makes it through? The universe is waiting for our answer. The cosmic silence is waiting to be broken. And the choice of what breaks it, a signal of triumph, or the echo of another civilization's last breath, is entirely up to us. So the next time you look up at the night sky, remember, you're not just looking at distant lights. You're looking at the greatest mystery our species has ever encountered, and you're living in the generation that might finally solve it. What will your part of the story be?